Hi, I received a few messages from you guys about these videos that somebody made high voltage generators, and I thought to myself, I do need a high voltage power supply because I have my own reasons. Now I have made a bunch of super high voltage circuits like my homemade taser that makes tens of kilovolts, or my Tesla coil or Van de Graaff machine that make hundreds of kilovolts. But I want something that's the circuit doesn't break down so easily and is more efficient. Should be easy to do. The concept is quite simple. In all voltage inverters, no matter what type of input you have, DC or AC, first you have to convert it to AC. Then, using some type of circuit, like typically a transformer, you convert the AC level to whatever is suitable for you and use it as is, or send it through a rectifier and use it as DC. And using my knowledge, it should be quite easy to design a very good and efficient circuit. How to make super high voltage. Hey look, my friend Jay from Plasma Channel made a 10,000 volt AC supply back in 2017. I'm late. Well, better late than never. Let's see how he does it. He's pulling his high voltage transformer out of an air purifier device, and he's gonna drive it with a fluorescent light ballast. Interesting. 15,000 volts? He promised 10,000 volts. He's over-delivering. Look at those arcs. Damn, let's do it. Oh wait, I need a transformer and a ballast. Oh wait, I have a ballast. The hell is it? Ballast. Transformer. Well, I guess I could use my ignition coil transformer. I like those transformers though. Oh wait, I have them, no? There we go. Like 2-3 years ago, one of you shipped me 3 of these transformers that due to poor packaging, their cores were broken, but I should be able to glue them back. So thanks, now I get to use them. One of them is good actually. We just have to figure out how the hell these work. Well, on the ballasts, they show the wiring. Well, basically the way the ballast works is that first you tie its input. Ow! What a dummy. Always wire up before powering your circuit, or maybe even think a little bit beforehand. Well, if you haven't watched my fluorescent light video yet, here's how fluorescent lights work. Basically, there is a small voltage across filaments that run some current through them so they warm up and vaporize mercury inside the lamp and makes it easier for the electrons to jump around. Then there is a much larger voltage between the filaments that results in plasma flowing into the lamp and glow and light up. So we just have to figure out which wire does what. I'm not sure how high the output voltage of the ballast is, so I'm going to use my differential probe that can take up to 700 volts. Hopefully that's enough. And I was thinking, I haven't done a Keysight scope giveaway in a long time, so let's do that. My sponsor Keysight is not only the provider of fantastic tools, they put a ton of effort to raise people's knowledge. They just started a great free Keysight University online program where you learn tons on not to shove your probe in the wrong spot. With their help, I'll give away one beautiful power supply, which I don't have, and 2 of these fantastic scopes. To enter the draw, you just sign up for free for Keysight University at learnkeysight.com page/ElectroBOOM, and you can learn how to use these and the supply I don't have. Because these deserve a good home. These long wires make me nervous. So, according to the diagram, it can turn on 2 lamps. Yellow goes to one side of the lamps and red and blue to the other side. And this is just the AC input. So, we should be able to turn it on. And electric tape is your friend. Just cover all the exposed wires. Okay? Well, we can't cover all the wires. We need to measure them. Oh my god, I'm an idiot. Well, first wire, then power. I don't see any proper voltage between anything. How does this ballast work? Tons of different transformers, as you can see, and I also noticed the fuse there. Hopefully that's... Why is the fuse broken? I have to short it now. Okay, I shorted the fuse. Now if the circuit is working, we'll see something on the scope. Makes you wonder why the fuse went to start with. Oh, oh, come on. My ballast is gone. Well. What do I do now? Hey. I just realized these CFL lights work the same way. There's a tiny ballast in them that turns on the light, but I don't know if it's strong enough to run my high voltage supply, but we can try. It's a terrible idea though. It exposes all the high voltages, so never try this at home. Quite dangerous. Look at these tiny transistors running the transformer. I don't know if they're strong enough. Well, let's measure the voltage before disconnecting the light. Ready? Let's plug it in. Hey, it turned on. Ah, there you go. Well, you can't see it, but it's 150 volt peak, which is less than the city power, which is like 170 volt peak. What's the point of this then? Maybe if I remove the light, the voltage rises? There you go, like the big fluorescents, the tiny CFL has 2 wires for each filament, and then this is the ballast circuit. We shall plug it in and measure the voltage unloaded. Ooh, what happened? I think the unloaded voltage is too high and the circuit blows up. I have to cut another light. Damn it. Why isn't life just as easy as everyone else shows in their videos? Just plug it in and it works. Okay, so my transformer primary is around 5.3 millihenry, and I noticed that my voltage frequency was around 60 kilohertz, which makes the primary impedance around 2000 ohms. So it should be safe enough to connect my transformer directly to that circuit. Well, I don't really know if my transformer can work well with 60 kilohertz. And not only that, if my transformer arcs at the output, it shorts all the energy, so it might blow the circuit. Well, at least let's see a tad bit of arcing action before the whole thing blows up. Nothing? Did it blow up already? No? Do we even have output voltage? The hell is that? Is it overloaded? Such a video. Nothing's working. Fine, let's see if using one of these transformers makes any difference. So many pins and I don't know which one is which. I'll just go with the one winding with the largest inductance to make sure I won't break my puny ballast. And I know this thick wire at the top is my high voltage output, and the other side of the secondary would be one of these pins, which we will figure out. Let's hope this ballast is still not broken and we might see some arcing action. Ready? And nothing. Why am I always stuck in such a horrible situation? Oh, look at that. There is a very tiny arc to some of the pins. Maybe I picked the wrong primary. Maybe I should go with the smaller inductances. Well, I accidentally disconnected the load and blew up my second ballast too, so down to the third one. At this point, I think this video is just too painful to watch. Okay, here we are again. This time I'm gonna pick up a small inductance for my primary, which means the highest turn ratio between primary and secondary. And it may kill my ballast, but at least maybe I get some arc. Here we go again. If there's anything, we shall see it together. And nothing again. Even worse now. I'm gonna try every single primary and see which one creates an arc. Oh shit! Disconnected the load again and killed my ballast. Left with no ballast, no high voltage power supply, nothing. Doesn't matter. I'm gonna go buy a new improved ballast. I mean, maybe I shouldn't have been lazy and designed my own fabulous circuit, but for now, let's just find a ballast. Ballast. Now I guess it's okay for these puny CFL ballasts to die when there is no load, because the load and the ballast should always be together. But for these ones, there is no guarantee there is a load, so it must not die that easily. Okay, so I'm just measuring between yellow and red, and hopefully we'll see something. Hey, hey, hey! Look at this, at no load, it outputs a very noisy 70 kilohertz AC with peaks of plus and minus 700 volts. 70 kilohertz. According to my pain versus frequency graph, 70 kilohertz is well above the level that would mess with your nerves and should just burn your skin. But 700 volt is not too high to burn very quickly. Should I touch it? Fine, just for science, I'm gonna touch it with one finger. Let's plug it in. There you go. But you never try this at home. It's 700 volts, very high. Oh my God. Should I touch it? Just a quick tap. Oh my God, scary. 70 kilohertz, I shouldn't feel it. Could burn my skin though. It won't even arc. What am I worried about? Just a quick tap. Hey, I was right. I can barely feel it, but it's funny. Whoop! I can see smoke rising from my finger. So it just burns. Just burns! You may see these lines where the wire touched my skin. It burns the skin, but I can only touch it very momentarily. If you touch it for any longer, not only it sets your skin on fire, but also it will get to the lower resistance tissue under your dead skin and everything will burn much faster. But I guess it's much less lethal than if it was lower frequency. So I'm thinking it should be safe enough to connect it across the primary of my ignition coil. I just electrical tape all the unused wires, although I'm still not sure if my ignition coil can work at 70 kilohertz. Well, let's just hope for the best. I'll momentarily plug it in while looking at the output voltage and hopefully nothing bad will happen. There was no voltage. Let's disconnect and see if the ballast is dead. Whew, still there. I connected the ignition coil primary to scope's function generator and checking the output at 70 kilohertz, there is nothing. When I reduce the frequency, only around 3 kilohertz I see a peak output voltage. So the ignition coil doesn't work at 70 kilohertz. You know, the way transformers work, you can't put too low of a frequency on them because the input impedance is so low it will short your supply. So they work in a specific frequency range, and at some frequency they resonate, and above that the output just drops to zero. Okay, no more connecting it to my ignition coil. Clearly it's not good for 70 kilohertz. Where's my other transformer? I connected the output to the largest inductance I could find on this transformer, but still it might overload the ballast. I'll check the voltage too. Let's see. Still nothing. Damn it. This video is full of a whole lot of nothing. None of my transformers work with this ballast. One thing I don't understand about these stupid transformers is that, see, when I'm applying an AC voltage to the primary, it is creating a DC voltage output, which is like 400 volts now. And if I touch the output, it can't sustain that voltage and quickly drops. That's why it doesn't shock me. What? Why DC? Does it have a rectifier at the output? What's going on in this thing? Hey, maybe there is some sort of rectifier at the output. After all, it was used to drive a tube TV. And if I'm not wrong, in those TVs you need a DC to shoot an electron beam to your screen to make the pixels glow. DC output? Really? Wow, look at all those diodes at the output. I tried my high voltage ballast on every single winding I could imagine, and the best arc I got from my output to this pin was this. Which is disappointing as f. Maybe Jay's ballast is stronger. This is warm. Maybe his transformer is better. I don't know. I hate dealing with random unknown components. I have to design my own. For my last act, I just connected my powerful ballast to my puny CFL bulb, and hopefully it will blow up magnificently. Make my heart a little bit happier. Let's see. It just turned on. Fine. Ah! It just burns! Giveaway time! So 2 4-channel scopes / function generators and 1 power supply that I don't have. to 3 winners who register for free from my link learnkeysight.com page/ElectroBOOM, where you'll get access to free online classes taught by engineers. Each class is under an hour long, covering things like electronic essentials, a bootcamp series, and master class on important topics across the test and measurement space. I mean, you don't do electronics if you can't measure. At the end of each class, you take a quiz, and if you pass, you'll receive an official certificate of completion you can add to your LinkedIn profile or share with your manager, and maybe ask for the promotion you deserve. This is what I love about Keysight. They understand when you help raise everyone, everyone will go up together. They keep launching new professional classes every week, and they're just getting started. So make sure to use my link, get in the draw, and start learning. And thanks for watching.